Okay, negative pi over 12. What did I tell you to do with that? Change it into degrees, right? So what is that really? Sine of negative 15 degrees. Okay, now you're only allowed to have 30 degrees, 45 degrees, 60 degrees, 90 degrees. What do you want to pick? And are you going to do subtraction or addition? Subtraction, okay, so 45 and 30, okay, so I'm going to say that we probably want to do it this way. Okay, so if I follow the formula that I've been given, y, x, y, right? And then what about the sign in between? Same or opposite? Same sign for sine. Thank you. Okay, so what's the sine of 30? 1/2. Cosine of 45? Radical 2 over 2. Minus cosine of 30? Radical 3 over 2. Sine 45? Okay, so obviously we should be getting something like radical 2 plus radical 6. Oops, sorry, not plus. Sorry, it was minus, my mistake. All over 4. Okay, that was question 10. Or radical 2 over 4 minus radical 6 over 4 if you prefer, leaving it separated. It's up to you. Some people file their taxes together and some people don't.
Which way is it cheaper?
Together, in my opinion. I mean, there's so many different tax laws. I don't know.
You can commit tax fraud.
Oh, okay, that's nice. I'm sure you can. Actually, I'm pretty sure you're right. Ah, nice. Okay, let's see. Next on my evil agenda. Yes. 18. Man, I wish I would have copied down those instructions.
That was the one I just asked you about where you said you just have to put it together.
Oh, yeah, you just have to put them together.
Yeah, it was 22.
I haven't done 22 yet, but I need to do 22. Yeah, I've already circled it because they asked me about it. So we don't need 18? All right, okay. That was a fake problem. Okay, yes. Is there a hand or just...
Yeah.
Okay.
Well, you're not there yet. I think it's 40 and
40?
and 44.
We'll see.
Okay.
Those sound like different types of problems, so that's a good possibility. Okay, tangent. Now, so all I'm being asked to do is decide whether this is 3 alpha and 2 beta. Am I going to add these together or subtract them? That's all I'm being asked to do here, folks. And your answer comes in the top. There you go. Wow, that's really all they asked me to do, right? Since I don't know what alpha and beta are. They just wanted me to use the formula and go backwards and simplify it. That's what all those questions were about. Okay, you were just being asked, hey, is question 20 a cosine or a sine? And then what are you doing? Is it a difference or a sum? Those are the only things you really had to decide. Okay. But those are the types of questions we did answer yesterday as well. So that's why I felt comfortable releasing you to the homework. Okay, now, moving on here, 40 you said? And 38 just for kicks and giggles, I guess. All right. So we'll put these two on our list. Maybe we'll just do 38 since it was asked first. Okay, tangent. Since I think we should probably use the cosine sine version. Why do you think I really think we should use the cosine sine version? Okay, what was the shaking of the head for? Did I miss something? Oh, okay. Well, I mean, we can forgive a little bit here if you did several. Why do you think we should do the cosine sine one?
Because let's look at how to do it.
Right, we're gonna run into a roadblock if you use the tangent version, because you're gonna have that pi over 2 in there, which is undefined. So we definitely want to use the cosine version, or the sine cosine version. So we've got sine pi over 2 minus u over cosine pi over 2 minus u. Okay, so let's see here. Sine would be y x x y all over x x opposite sign y y. I'm just following the formula, folks, plugging stuff in as we go. So what are we going to replace for the sines of pi over 2? Aren't those ones? Right? You're at the top of the circle. It's the y value. So we got 1 times cosine u. And all the way over there, after the plus is a 1 times sine u. Okay, and then how about the cosine pi over 2? What do we got for that? 0. Okay, so 0 times sine u and 0 times cosine u. And then those two terms are disappearing. Are they disappearing because I canceled one factor from the top and the bottom, or is there a different reason? Multiplied by 0. That's it. So we have cosine u in the top and sine u in the bottom. What's that? Cotangent u. Hey, look, we proved it. Okay. It'd be 1 over cosine. All right, so on question 40, the difference that I see with question 40, which makes it a touch trickier, is that this would be 1 over cosine of pi over 2 minus u. So that's the only difference, is that your formula will be on the bottom of that, and then you'll look for what cancels, and I'm guessing something.
Go along with the cosine formula.
Yes, it does go with the cosine formula for that denominator. Okay? So, okay, was there another one towards the bottom here? 48. Okay, 48. 40, I just discussed that with everybody and what you need to do. In fact, let's see if I hit the undo button, I can show you what we talked about. Secant is 1 over cosine, and then you would just go to the cosine formula and put the parts across the bottom and see what happens. Okay? What cancels and what remains. Okay. So, question 47. 48. Sorry. So we have cosine x minus y and cosine x plus y. Okay, so let's see here. The cosine function, that was x, switch signs, y, plus, then we had x, opposite sign, y. Why did the sign in the middle stay the same? That's not part of the cosine formula. That's part of the expression that they've asked me to add together. So what you saw me replace, this part here goes with this. And then this part here is the second part. Okay? That plus in the middle is part of the expression, not a part of the replacement substitution. Now, does anything look like it cancels out? Ah, that's right. Those, one's positive and one's negative. Leaving you how many of these cosine x, cosine y things? 2. Oh, you mean we're done with the proof? Okay, so those weren't terribly difficult, but yes, you are following the formula that we've been given this whole. There were only 3 formulas for this particular section to really use. I mean, I know the tangent had the other one. What's the other question? What's going on? What can I help with?
You explained this, but I was right now. Like, how did you get from like the where you circled it red, like
Yeah.
the cosine x cosine y, to where you circled it blue?
Okay,
Like
so
what?
the blue one was over here.
Oh,
Okay, and the red one was this one right here.
okay.
Okay,
So then,
Then
why did it
these-
change? Because it's cosine. Okay, never mind.
you got one pot, or yes, they changed signs
Yeah,
according to the
okay.
formula.
Sorry, thank you.
No? Does that really help enough on the homework, or is there another type of problem, different type that we haven't done? I mean, I'm all up for doing a different type. If there's a different type you want to look at. 14. Okay, so question 14, you can either leave it as radians or you can change it to degrees. I don't care which you prefer. Do you have a preference? Radians? Okay. You want to go degrees? Okay, so if we go to degrees, obviously that's 60 degrees. Pi over 7. What is 180 divided by 7? Yeah, what is that? 25 point something. I think it's 25.4, something like that. Ish. I mean, it goes on. You want?
Yeah, I think radians is easy.
I don't care what you do. Okay, now. The important thing is, do you know whether it's a sine or a cosine? It's got to be a sine because it's yx, xy. All right? So, what are we going to do with the 25.4 and the 60? Do we subtract them or do we add them? Sine has the same sign, right? So 60 minus 25.4. So if you're in the world of degrees, you're gonna be getting something like what? Sine of, whoa, not a negative. What am I? Okay, switch. Oh man, what am I doing? Do that. Do that. Oh, that is the wrong thing. I wish I was better at what I'm doing here. 60 take away 20 is 40. Take away 5 more is 35. So we're talking about 34.6-ish. Somewhere in that neighborhood. Now, if you do go with the world of radians, and you want to take pi over 3 and subtract pi over 7, okay, you know it's a sine. We need common denominators, don't we? So what are we gonna do there? 7 pi over what? 21 minus, how many pi's over 21? Oh, 3 pi. Sorry. My fault. I was thinking ahead. Okay, so sine of 4 pi over 21. So those two would be your equivalent answers. Yes.
So do you have to go all the way there, or can you stop once you have a pi over 3 by 5 or something?
No, you can't do that. You got to go to the end. Stop in the middle. Who does that kind of thing, man?
It's like
You're going to get run over if you stop in the middle of the road. Stop it. Okay? You got to get all the way into the parking space. Okay? Stop in the middle of the street. Get smashed. What? Or the red light. Yes, you need to stop at the red lights. Okay? With their eyes. Don't they?
Mom wants to say like what shade of green.
I mean, he didn't ask you. Never mind. Okay. Okay, let me go grab your copies for with me. There are more formulas in town.
I don't like that.
That's right, man.
Let me get out.
Double angle identities, man. This is like secret spy stuff, you know, where you don't know who's really, you know, on your side, you know. Okay, double agents. That's what I was going for here. Okay. Now, where did these kind of things come from? Yes, yes. So what is the sign? What's u plus u? 2u. Or to me, whatever. But right there is the sign of 2u. Now, yes, we could go through the formula, right? Yx plus xy. But what you get... Okay, a song idea. Nothing compares to what? To you. Nothing compares to you. It's right up there with everybody do math now. Dun, 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 dun.
Can you try to make like a line sheet out of all of these?
Could, maybe. We could do that. We
Can
can.
you make a CD?
CD? Yes, I should make a CD, man. I know. I've got plenty of people that have already, you know, said things like that. They want to buy my.
Yeah, put out the pre-orders.
Yeah, pre-orders. Woo, man. Okay, folks, now, if you look at the next one, cosine 2u, they have 3 different forms of it. Okay? I want you to look, and now I copied the paragraph below this because I had to, folks. We list the 3 identities for cosine 2u because they are all useful in various contexts and therefore worth memorizing. I cracked up laughing when I saw that. Okay, will they be on your formula sheet? Of course they will. Okay, so I'm like, worth memorizing? I'm like, now, the only reason you memorize them is because you've used them so many times. That's nobody sits down to memorize these, okay? You might happen to know them because you keep doing them over and over and over. Otherwise you're just going to be like the rest of us and look them up on the formula sheet. Okay, but there are the double angle identities for sine, cosine, and tangent, and we will be using them. So it's not too hard to figure out what to use for sine 2u. It's not too hard to figure out what to use for tangent 2u. Cosine 2u, you've got to think a little bit. Sometimes there's a little bit of trial and error. You put the wrong one in and you make more work for yourself. And so you have to go back to the drawing board. Okay? So proving a double angle identity. Okay, so this one's not too bad because we basically just talked about this one out loud. So sine of 2u is equal to sine of u plus u. So I'm actually going to pause this, let you work out the proof using your sine formula from the last section, okay? And then we will see if you and I agree. Oh, that's the wrong button. Sorry. That's what we should have had. Okay? It was basically one step. You just had to plug u and u into the sine addition formula. Remember yx plus xy? And then they're like terms, so you can add them together. So you get 2 of them. End of proof. It really was just that simple. Yes, except we know from the multiplication property, the commutative property of multiplication, that we can 2 times 3, 3 times 2 are both the same. So we can swap those in multiplication and still have the same exact terms. Good question, though. Whoa. If you need to reduce your powers, yeah, we got some power reducing formulas. We can get rid of squares and transfer them into linear powers. So they're telling me that cosine to the 4th of theta minus sine to the 4th of theta is equal to cosine 2 theta. We've got to prove it. How do you think I should write or change cosine to the 4th theta? Or do you think this is the difference of perfect squares? Could we treat it as a difference of perfect squares and factor it? What can we break this up into? Cosine squared theta and cosine squared theta. And what are we going to do with this? Plus and minus, that's true. Sine squared theta, we got a plus, we got a minus. Doesn't matter which one you put in, which, okay. Does anything look familiar? What? Okay. All right, fine. You want to make me feel bad? No, my 2 there, seriously. Okay. Come on, what's that green box? 1, thank you very much. I so appreciate that. Wow, that's nice. Nope, they're not. Yep. Don't speak heresy. Okay, so we got it to this point. Why don't we use the formulas up above? Cosine squared theta. Okay, so we're going to go to the middle one here. Yes? Because I'm trying to replace this thing right here. And then I'll go over there and do the other one. So I'll do both of these. I'll just do it one at a time because I'm not that good. So I'm going to try to scooch this up a little bit so I can write 1 plus cosine. Oops, that's, oh man. Somebody's going to make fun of me over there. Cosine 2u all over 2 minus 1 minus cosine 2u 1 minus cosine 2u over 2. Okay? If only these had common denominators. Okay, do they have common denominators? Okay, that's cool. All right, so we could put it all together, right? So 1 plus cosine 2u. Okay, So this minus is going to get distributed to both of those. So that's a -1 and a plus cosine 2u. All over 2. Does anything cancel out? Anything?
2 to 1. Once.
Oh, because there's 2 of those things in the top. It's like a serial killer movie. A lot of slashing going on. Cosine 2u. I know. You're doubling the angle. It's not a coefficient to the cosine function, all right? That's like, okay, if I asked you this question, all right? How about 2 radical 6 over 3? Okay, can the 3 go into the 6? No, because they're not both inside of a radical. The only way you can reduce is to look on the outside. Does that make sense? That's kind of the idea here. Okay, let me show you a good wrong answer here. No, I didn't hear what you said. What did you say? Well, they like to stick with even powers. This is a good wrong answer and a good way to lose all the credit. Okay? Because look, there's no power that's greater than 1. Okay, that ain't it, Chief. Okay? All right. Because there is a power, a 4th power. Just because you, that's like when people say expand a plus b to the 5th power. Okay, you get answers like this. Yeah, that's yeah. No, but that is if you go out and look at different mathematical test answers, that you will find that one out there. Actually, yeah, they have it. It starts small and it just keeps growing. Okay, so we're not writing it like this. Okay. Whoa! I almost got it all in one swipe. That was pretty cool. Wait. Okay, so let's back up here. All right, cosine squared x. No, plus would not work. Times itself, right? Okay, we're not done. I just started this. Yeah. Okay, now. So everybody got that? We split it into cosine squared times itself. Is there anything that might be useful in this box? The middle one, right? Okay, so let's put those together. 1 plus cosine 2u. Plus cosine 2x plus 2. Is it 1 plus or 1 minus? 1 plus. Okay, I just wanted to make sure I wasn't off my rocker. Okay. Now what? Sounds like a job for foil, isn't it?
Wait, you have the foils?
Yeah. We gotta foil this. That's what we are doing. Okay. All right. So if you're foiling it in your head, that's good. Okay. So we got a 1 plus. Okay. Do the outsides and the insides. What do you got? How many of those cosine 2x's? 2 of them. because the outsides give you 1 and the insides give you 1. All right? And then the lasts give me cosine squared 2x. I knew that would be a confusing one, so I thought I would write it out for you. On the bottom, 2 times 2 is 6. Don't listen to that kid. Okay? Okay, now, if so far we have a 1/4 plus, if you could reduce this term, what would you get? Cosine 2x over 2. We could also say that is 1/2 times cosine 2x. Now, if they have told me in this problem that I can't have a power greater than 1, so far the first 2 terms are looking fantastic, because neither one of those has a power greater than 1. But I got this other issue with the last one. Right? Because the last one still has a square in it. So what can we do with this thing? We're going to go back to that formula you were using, right? The one from the middle there. So we got the 1/4 out in front, and what are we replacing this with? 1 plus cosine. Now, here's where we have to be careful. This isn't cosine squared x. This is cosine squared 2x. So, what is going to go right there? 4x, right? Because you're doubling the 2x. That's a little bit different. Okay? So my final answer here, 1/4, that was a good term, plus 1/2 cosine 2x, that was a good linear term, plus, what's the last term? 1/8, good call. That's 1/4 times 1/2 right there. Okay, and maybe just for my sanity's sake, maybe I should separate it into these two, just so that in my mind I can write this out. That would be 1/8 plus 1/8 cosine 4x. Sorry. Are there any like terms in that group that I could add together? I can't add the cosines together because one's a double angle and one's a quadruple angle. There is something that looks a little bit like I can add it together. This one and...
How did you know you had to break down the cosines?
Because they said I could not have a power over 1. If you look back at the rules of the game, they said rewrite cosine to the 4th x in terms of trigonometric functions with no power greater than 1. So since I still had a square in it, you remember last year in Algebra 2 when you had a radical equation and they had radicals on both sides of the equation and you squared it, but then you still ended up with a radical and then you end up having to square it again? That example is similar to what you're doing here. You're replacing one of them with cosine, the cosine x squared formula, but then you had to do it again because you had another one of those squared terms in there. Yeah, now you could see in their answer down there at the bottom, they left the 1/8 and the 1/4 separated. You know what? If you did all that work, I think I would be okay. I don't think I would squabble over having to add the 1/4 and the 1/8 together. But no, you can't add those other terms together because one's got a 2x and one's got a 4x. They're not like terms.